and we're here to talk about a very interesting geologic site in Monteagle, Tennessee. These sediments are from the Mississippian and Pennsylvanian time period, which makes them up to 350 million years old.
What? No way!
Yes, that is right, Jesse.
Well, how do you do that?
Well, through the science of geology and paleontology, we can piece together information from rocks and fossils to put together past environments.
That's so cool. Well, how do we do it?
Well, let's take a look in my office and I'll show you how. Well, one of the first things we do to help determine the depositional age and environment of rocks is by looking at the different layers. My colleague, Dr. Theodore Willoughby, will show you some samples and explain.
Okay.
Hello, I'm Jesse.
Hey, name's Theodore. My girlfriend calls me Teddy, though.
Nice to meet you, Teddy.
Hey, I've got a few samples here, and I'm going to show you what their lithologies are and explain to you what those mean.
Lithmology?
Lithology. It's the general characteristics of these sedimentary rocks.
Wow, neato!
Well, Chad, let me show you something here. Here we have a few hand samples that my team and I collected out at the field. First things first, we're going to drop some acid on them.
Drop acid? My mother always told me to say no to drugs.
Not LSD, Chad. Dilute HCl. We can drop it on these rocks to determine their lithology. If we drop acid on the rock and we notice a fizz, it indicates a carbonate lithology, which could mean a warm climate.
That's so cool.
That's right, Chad. And as we move up in elevation through our outcrop, we notice a change in lithology from the limestones into a sandstone and a coal bed.
Well, what does that mean?
It's a sequence boundary.
Sequence boundary? What is that?
Well, Chad, a sequence boundary is when you find two lithologies together that would normally not be found in close proximity. In this case, they signify the switch from the shallow seas of the Mississippian to the coal peat swamps of the Pennsylvanian.
That's so crazy. But what are all these tiny things inside these samples?
Well, I think I'll let my associate, Dr. Scat Britches, come and explain that to you.
Okay.
Well, I think I can help with that, Chet. Hey, I'm Britches. Scat Britches.
So do you think you can help us out, Scat Bridges?
Well, sure, Chet. These are fossils.
Fossils like dinosaurs?
Oh, Chet, sure, like dinosaurs. And like dinosaurs, these fossils can tell us about the age and environment that they came from.
So what do these fossils say to you?
Well, Chet, the first thing that I hear from these fossils is their names. Crinoids, Archimedes fenestrate bryozoans, gastropods, and blastoids. However, what you want to focus on here is not the blastoids. Yes, the blastoids. Not the gastropods, not the crinoids, but the Archimedes and the blastoids. These fossils are indicator fossils, and what they tell us is that this was a warm, shallow sea, and probably from the Mississippian. Now, Chester, if you see a sequence boundary,
Sequence boundary? Like Teddy told me?
he already knows.
Learning is fun. So you're telling me that the Monteagle Mountain used to be underwater and in a tropical environment?
That's right, Chaz. About 400 million years ago, Pangea was splitting up, and the area that we've been studying used to be in a tropical area around the equator.
Wow, this has been interesting and informative. I can't wait to go tell all my friends what I've learned.
I'm glad you think so, Chaz. Don't forget, geology rocks.